everyone. A very warm good evening to all of you, and thank you for joining us for today's event. Today is our first winter event, first event of 2021 after a very interactive and fun Christmas event. We are hosting our first event of the year. It is our 24th event as well. So almost for 2 years, we've been organizing events for the Python community in Berlin and everywhere else. So we're really excited to have all of you with us. Before we start with our speaker sessions, we have a short intro for all of you. So first of all, why PyBerlin? Well, it's Berlin and we all love Python and we also love the TV tower. So the Python snake climbed to the TV tower and say, hey, here is PyBerlin. We love sharing ideas. We're all based in Berlin and we're welcome to everyone who is interested. Our organizers are Anastasia, who is handling the streaming today, Shreya, myself, who will be being your host for the first part of the evening, and Theo, whom you'll be seeing at the end of the event and in the middle as well. So thanks for joining. It is also our 10th online event. I think we started way back in April when the lockdown happened. And since then, we've been continuously organizing events every month. So thank you for all those who stayed with us, who are joining us. And we hope that you keep on joining us for the next few events as well. So we don't have many rules or regulations as such, but we do request all of you to be nice to each other, be patient, and respect each other's presence. There's also a code of conduct that you can find on the link mentioned on the screen if you're interested. But in general, all that we request from you is just be nice. It is very safe to ask questions. There is no feigning surprises or, well, actually, just feel free to ask the questions. No subtle isms. By isms, we mean racism, sexism of any sort. It's a very open platform. We promote everyone from every community to use this platform to showcase their work related to Python. Today's event is sponsored by ScoutB, that Anastasia made it possible. So thank you so much, ScoutB, for helping us with Zoom links and making this platform available for all of you via Zoom. Today's agenda, we have two very interesting speakers for today. The first one is Christian Barra, who would be talking about what developers and data scientists should know about Kubernetes. In fact, Christian was one of the founding members of PyBerlin, and we're really excited to have you back as a speaker, Christian, today. Our second speaker is Max Williams. He is working at Delivery Hero, and he would be talking about why you should be load testing and how to in Python. We're really looking forward to both the events, but before that, a few more announcements. We're looking for organizers. If you're interested in organizing these events, right now they're mostly online, but we do hope that soon we can make in-person events also possible. So if you're interested to be part of this or understand what goes behind organizing such events, it's also good to add to your CV. So if you're interested in doing this, then please reach out to us and we would be more than happy to have you on board. We are also looking for speakers. So if you have anything interesting to share, or if you want to share some project or personal work that you're doing, then please feel free to reach out to us. When we say speakers, do we mean just professional speakers? Well, not really. We're looking for people who have something to share, any small project or anything that you would do something related to Python. You can use this platform of PyBerlin to share your work with a larger audience. We have two formats for the talk, a standard 30-minute talk, which would be a longer duration talk, and then a lightning talk, so 5 to 10 minutes. It is up to you if you want to take questions or not. If you're an early speaker or if you're a new speaker, and if you don't want to have questions, then that's also possible. It's totally up to you. And we welcome people from all communities to use our platform and share their work with us. So if you're interested, then please submit your talk proposal here. You can use the QR code on the screen. You can also reach out to us on our meetup page or on Twitter, and we will schedule something according to mutual convenience and have you on our platform very soon. Our next event is on February 22nd, 2021. It's a Monday. So please put a blocker on your calendar, and we hope to see you all next month as well. And thank you. Also, throughout the event, if you would like to tweet about our event or just give feedback or say what you liked, what you didn't like, we are on Twitter as well with the with the handle @PyBerlin-Python. We would really love to hear what you think about our event. And you can also join our Berlin Python community on Slack. And the link is on your screen, pyberlinslack.herokuapp.com. And also, when you read about us, please follow us on Twitter as well. A few thank you notes to the amazing people who made these presentations and these icons possible. And the free assets and resources were presented by Slides Carnival and Unsplash. And people who help with logo and story are Elena, Konstantin, and Christian Barra. In fact, Christian is a speaker as well with us today, so we're really excited for that. Just a quick suggestion, those who are I would request everyone to put themselves on mute if possible. And with that, we welcome our first speaker, Christian, who would be talking about what developers and data scientists should know about Kubernetes. So Christian, over to you.
Hello. Just give me a second. I need to share my screen. And I need to find with Zoom. So share my screen. Okay, cool. Can you see my screen? Yeah, okay, great. Yes. So I'm really happy to be here. It's been a while actually, and it's been a while since I've been speaking in an event here in Berlin, even if it's just online. I'm really grateful of having this occasion. So today I want to talk about Kubernetes and what developers and data scientists should know about Kubernetes. Okay, cool. Just a bit about myself. I'm currently based in Berlin. I can't wait to go somewhere else. Hopefully the lockdown and the corona condition will improve, and sooner or later can experience some summer somewhere. And I run pybootcamp.com, which is a training and consulting company with a focus on Python and DevOps, and I'm a Python Software Foundation fellow. So there are just a couple of things that I will really like you to get out of this talk. And the first one is that I want you to develop a sort of interest in Kubernetes. Like, okay, after this talk, I want you to, just Google a few things and, spend some time learning this great tool. And the other thing that they want you to do is to understand the things that you can do with Kubernetes and how Kubernetes can help you achieving something. So I spent enough time in technology and in software in general, and I had a lot of random conversation with engineering managers, product owners, head of something, and director. And especially in the last years, a lot of them were mainly related to, I don't know, there is a data science team and it's not delivering. They spend a lot of time prototyping things, but then they're not able to deploy any of these things to production, or they write a lot of code, but it's not production ready, and we don't know how to to get value out of this. But this kind of problem is not just related to data science team or teams which are not under engineering. Another thing that that really often I hear is that teams are too slow, or we release features, but we release feature only, I don't know, once every 14 days. Or the PO is complaining that, why is taking so long to, release something or deploy such a small feature, or why we have a bug and it takes 2 weeks to fix the simple thing. And these are all symptoms that can be connected to many different causes. And this is not really the topic for today, but it's just a way in which Kubernetes can help. And usually behind the symptoms, there are, again, different causes, and sometimes it's a different mindset. So often the problem between data science not delivering value is just a problem with mindset. Sometimes there is a problem with the deployment pipeline. Other times it's because your software is buggy and you're really afraid of doing releases or doing deployment. And another possible cause is lack of tools, lack of proper tools. And this is where Kubernetes can help. I really love this comment, which is something that I found online when I was Googling about Kubernetes. And they're these two guys talking about, we really need to move this application to the cloud. And this hopefully should solve all this problem. And then they have this sort of argument, but this thing is not really working because he didn't let me spending some time improving the application. And the other guy says, but you can just put it in containers. But the other guy replies, you cannot fix things by just saving hype using, I don't know, hype names. And the other one replies Kubernetes. And that's often is the kind of feeling that you have around Kubernetes, like everyone is talking about Kubernetes, but no one is really knowing what you can do with Kubernetes or using Kubernetes in a proper way. I see that companies often, they have like a Kubernetes strategy, which doesn't really help them achieving what they want to achieve. So what is Kubernetes? Or what are the things that you can do with Kubernetes? So the first and most important thing is to really understand what is Kubernetes Undo. And Kubernetes, first of all, it's an open source system. It's a system, so it's a mix of different things. It's not just a single application. It's made by different components, and we're going to see these components later. But it's not just a binary that you can deploy. It's not just a thing that you can install and then you get, I don't know, Kubernetes ready virtual machine or cluster. And the thing that you can really do with Kubernetes is to deploy, scale, and manage workloads. And they are mainly containerized. So you can deploy, scale, and manage containers. And you can do this at scale, like whether you have 1 container, 2 containers, 3 containers, or thousands of containers. And the other thing, because Kubernetes is not just a binary, it's a system. It's really, it's an application. I think it's important to talk about the Kubernetes architecture. And I think that this picture is really helpful, because if you think about Kubernetes from the outside, it's really like a collection of Lego. Like you have all these components that you can put together, and then you can build an interesting system, but still from the outside, it looks like a lot of mess, chaotic system. And if you can see the picture, there is a 4+, which is not about the year, but it's about the number of team members that you need to have to run Kubernetes in production. So I really love this picture. I think it's really describing Kubernetes, the main components of Kubernetes. And there are mainly 2 components inside Kubernetes. One is the master node, and the other one are the nodes or the workers. And this distinction is important because the master nodes holds all the important components. Usually we can call the master node like the control plane. It's a Kubernetes brain. And inside the Kubernetes brain is where we store all the information related to Kubernetes. One example, there is the API server, which is the central component that you're going to use to interact with the Kubernetes API. Then we have various controllers that are controlling and taking care of creating application or orchestrating containers. There is the scheduler component, which is in charge of managing the workloads across the worker nodes. There is a cloud controller manager, which is it's not a component that you have always, but it's one of the components that you have when you use like a managed solution. So if you're using AWS, GCP, like GKE, or another solution from Azure, the cloud controller manager is the component that connects the cluster with the cloud provider API. So for example, if you need to create a load balancer when you're using like a manual solution, you have the cloud controller manager that will do that for you, connecting to the cloud provider API. And then there are other components which are not really important from the developer perspective or from the data scientist perspective, but they are only part of a master node. These are the things that you don't see and usually you don't manage when you're using a managed solution. And then on the right side, you can see the things that you have inside the worker node. So you have kubeproxy, which is a networking layer to connect your containers or your Kubernetes workload with the rest of your cluster. You have the kubelet, which is pretty much the agent. So it's connecting your node to the Kubernetes API. And then you have a container runtime, which basically is the runtime that runs Docker images. And if you're like inside, I don't know, DevOps network, or if you read something about Kubernetes and Docker, you probably heard that Kubernetes just deprecated Docker. But it's not that we're not going to run like Docker containers anymore. It's just that they deprecated Docker as a container runtime. So they're going to switch to another runtime in the future. And last but not least, there is this important part, which is etc. And it's the storage that Kubernetes uses to store data related to the cluster state. So when you deploy an application or a pod or any sort of resource inside Kubernetes, it ends inside the etc database. And Kubernetes is at the end a really collection of objects. So you can deploy like basic objects, which are defined, the one that are defined by Kubernetes itself. And you can think about pods, you can think about jobs, you can think about deployments, but you can also create your own resources. So you can define resources that you need that maybe behave in a different way compared to the built-in resources. And as you can see, and these are just about the workloads, like you really have many different kind of definitions. You have horizontal pod autoscaler, you have deployment. The deployment is connected to a replica set. The replica set is connected to a pod, and then like a pod is connected to a container. So as you can see, it's really complex. Like it gives you a lot of freedom, but at the same time, there is a lot of complexity. And another way saying this is like, what are the resources that are really exposed to a developer or a data scientist? And as a developer, for example, some of the resources that you probably use are deployments. So usually you cannot run a container on Kubernetes because the atomic unit is a pod. So the only thing that you can run, like the smallest unit, is a pod. But usually you prefer to deploy pods behind the deployment. So probably the most common resource that you can use is going to be a deployment plus a service for the networking part. So sure, there are like many components, and again, it gives you a lot of flexibility and freedom. But at the end, as a user, as a developer, you're going to rely and you only need to learn just a couple of them. So again, for a developer, for example, something that's going to be really useful is to learn about the concept of deployment and how you can write a manifest for deployment. The other thing that probably is really important is to understand how you can write a pod specification using the YAML JSON format. And probably if you're a data scientist, it's probably more interesting to check about how you can define a job manifest for Kubernetes or a cron job, always in Kubernetes. And another important thing is that running Kubernetes is different from using Kubernetes. Like the administrators and the user as a developer, they are two completely different roles. And I think often people are somehow afraid of, okay, if I need to use Kubernetes, I also need to run Kubernetes. And this role are like, they can be the same depending on the size of the company, but most of the time, they're two completely different roles, and you really need to have two different kind of skills. So there are multiple ways that you can try and you can experiment with Kubernetes. I'm going to share some of them before the end of the talk because I have a demo. But okay, like we got some knowledge about Kubernetes. We learned that it's a system to manage containers, to run, orchestrate Kubernetes containers at scale. But what is for a developer? And there are a few things like why Kubernetes is really important for developers. And the first thing is that it's a software-based and programmable infrastructure. So as a developer, you can really script, you can really code how you want to, your application to run inside Kubernetes. You can declare all the functionality that you want to have. You can declare by using code or YAML the amount of CPUs that you want to have, the amount of RAM that you want to have, all this sort of information. So it really brings the infrastructure closer to a developer. The other thing really important is that it reduces handover. So it's not like, okay, I'm going to create a Python application, then I'm going to do the handover to the ops team. No, the process is different. I'm going to create the application, and then I'm going to create definition manifest to deploy this application inside Kubernetes. And then, like I said, really bring the dev, the ops part even closer. So it's not that you have to worry about virtual machines or creating EC2 or any other sort of virtual machine on a cloud provider, but you just have to worry about, okay, is my kube control configured correctly, so I can just deploy this application using a proper manifest. So that's the only thing that you will have to care about. And the other thing is that it's becoming really a thing. Like I heard this concept every day. It's becoming like a normality that developers are expected to build something and then to run their application. So this thing about reducing handover is really becoming a focus for companies. And when this thing is still happening somehow, because I don't know if you have an ops team and and a development team, and they don't work close to each other. Usually this is in like a problem. Like, especially in the last 6 months, I heard a lot of companies that this is something that we're going to deal. This is something that we're going to fix in the coming months, because developers they need to build but also run their application in production. And for data scientists, this is slightly different. So data scientists usually are not expected to bring the same set of expertise or knowledge in running application compared to a developer. But also on this side, I see that there is a shift in the expectations. Again, the focus is always to reduce the handover, so to reduce the time between building something and deploying something. And it's really about getting the user, getting features to the user as soon as possible. And while for developers, like you build it, you run it concept, it's probably more common than data scientists. Also for data scientists, the idea of full stack data scientists is becoming more common. It's becoming like a thing. And another important thing is that it gives data scientists the freedom to run their workload. Like before, I don't know, maybe you had to create an AWS account and ask for an EMR cluster or a Redshift cluster, or I don't know, a Spark cluster. Now, using open source tools, you can say, okay, I have a Kubernetes cluster just for us. And as soon as you learn something about manifest, about jobs, about cron jobs, or about running Airflow for Kubernetes inside Kubernetes, like you're free to and you have all the power and all the tools that you need. And always for data scientists, there are a couple of tools which are really made for Kubernetes. Like if you think about Kubeflow to manage machine learning workflows on Kubernetes, there is also Airflow, not for Kubernetes, but you can use, you can run your jobs on Kubernetes by using directly Airflow. And the other thing is that you can use Dask, and you can use Dask for Kubernetes, so you can schedule your works directly on a Kubernetes cluster. And these things they make using Kubernetes with data science workflow really, really easy. And it really empowers the user, it really empowers the data scientist. So I'm gonna stop sharing the screen because I wanna create a Kubernetes cluster together. So I'm gonna share another screen. Okay, cool. Hopefully you can see my screen. And
yep, all good.
Okay, great. So I created a simple Django application. The idea is not really to focus on the Django application, but to see how we can run this application inside a Kubernetes cluster. So There are multiple ways of running a Kubernetes cluster. You can follow the R way, but I'm going to suggest a completely different way, which is using a tool called K3D, which is it's a distribution. It's a Kubernetes distribution made for small environments, for small IoT devices, or I like to call it like a simplified Kubernetes version. So it's a really simple tool. It comes with a CLI, and you can define your cluster.
Christian, could you please zoom in, because on the stream it's not quite visible.
What about now?
I think it's better.
Is it better?
I guess, yes. Thank you.
You read? Okay, cool. So the idea is to use K3D, which is a small CLI around K3S, which is the Kubernetes distribution. And the idea is to really create a Kubernetes cluster. I'm going to call it my cluster. And then the idea is to expose the port 80 of the cluster on my port 8081. So I'm just binding ports because I'm running it on my computer. And then I want to create two nodes, two worker nodes. And I can do this by specifying the agents flag equal to 2. So I can just press enter, and then I'm creating a Kubernetes cluster on my computer. And it takes just a couple of seconds. And the cool thing is that K3D gives you the opportunity to run Kubernetes inside Docker. So if you have Docker and you need to have Docker on your computer to run it, then you can type docker ps, and you're going to see that you have a couple of containers. You can skip the K3D proxy and we can focus on the agent. So I said that I want to create a Kubernetes cluster with 2 agents, and these are the agents. And then you see the other one, which is the master. Cool. So now I have pretty much everything I needed, and I can use the queue-control CLI to connect to my local Kubernetes cluster. So again, as you can see, I have 2 workers and one node, and I don't have any pods running on my local Kubernetes cluster. And the idea is to deploy the Django application that I created before inside my Kubernetes cluster. So the application itself is really easy. It does just a couple of things. But what I want to do is I want to expose the L check. So there is an L check that returns the git hash, the host name, and a couple of other information. And I want to run the application. I want to deploy the application inside a Kubernetes cluster to see it works. And you can, like, there are 2 different ways of deploying application inside the Kubernetes cluster. One is you can use the CLI directly, or you can use a declarative way, which is the one that uses YAMLs and manifest. And here I have 2 manifest. It's not really important to go through this right now. But here is how you define a deployment, which is basically an application inside Kubernetes. So you can define the number of replicas. You have a couple of match labels, which are not really important right now, but they're basically the name of your application. Then again, you define a name, and you define a Docker image. That's pretty much what you need to do. And if I go back to my CLI, I can just run kube-control, apply, f, infrastructure is the folder, and app.yaml is the manifest. And then you can see that Kubernetes is trying to create the containers. And is creating 3 pods because before I said the replica is equal to 3. And like I said before, deployments, they sit on top of pods. So I defined that deployment, and this deployment had 3 pods. And as you can see, there is only one deployment, which is the Django app. But we have 3 pods. So cool. So now the containers are running. And I need to do two things. I need to create a service. So I need to create a network abstraction, basically a software load balancer in front of my deployment. And for this, I need to use a service. So basically, I specify another YAML manifest, and I specify the name of the pods that I want to load balance and the port for the pod, which for this application is port 8080. So I created the service, and now I can see that there is a Django app service. And now the last step is to create an ingress. And the ingress connects the Kubernetes cluster to a load balancer, which is always running on my local machine and is managed directly by K3D. I know that like all these services and ingresses looks really complex, but most of the time they are managed directly by your cloud provider, so you don't have to worry about them. So now if I go back to the ingress, you should see an ingress here. I can call again my kubectl describe ingress, and I'm going to see some more information about my ingress. And I can see that here you can see the pods that like the endpoints for the Django app. So now what I can do, I can just go here. I can call localhost. Cool. I can call the LZ, and this is my my Django application, which is running inside my Kubernetes cluster on my local machine, and is currently returning the payload for this endpoint. So with just 3 manifests, which are the ingress, the service, and the app, we were able to run Kubernetes, like an application inside Kubernetes. And the interesting thing is that the files are the same, whether you're running on your local machine or a cluster on AWS or on GCP. Like the structure and the format doesn't really change. And this is really powerful. Like it really brings like your computer to the production environment. It really brings these things together. I think I'm running out of time. So just in case, if I have 4 or 5
you have
minutes.
more time. Yeah, sure.
Okay, cool. So the other thing that I want to show is, let's say that I want to change the deployment. Like I want to do a new deployment, and I want to change the application because I have a new version. So I want to change the image, and I have an application. I have a new image for the same application, which is broken. And the way in which you deploy this is that you just call the file with the change, and then you call kubectl apply, and you apply the new manifest. So now if we check the API, if we check the pods, you will see that there are the previous containers running. There are new containers that are being created. And there is one pod which is terminating. And what Kubernetes is doing an update, is doing a rolling update. So it's creating a new container with a new image and is turning down an old container with the V1 version. And it keeps doing this until the old set of containers, the old set of pods are changed with the new deployment. And if I keep calling my endpoint, you will see that the status now is different. So because now the container is broken, it returns K1. And it's also interesting to see how Kubernetes is load balancing the pods. So the host name is unique for each pod. And as you can see, like every time that I every time that I reload the page, the host name is different. So like load balancing is working correctly. But the interesting thing here is that we just deployed a broken application. Like, wouldn't it be useful for us to let Kubernetes handle this? Like, hey, Kubernetes, if the application doesn't work, please don't complete the deployment. And we can do this. Like, there are different ways of doing this inside Kubernetes, and one of the most effective ways is probably using probes. So I think I don't have time to explain like what probes are and how you can use them, but basically there are controls that you can run on your containers to see whether things are working correctly or not. In this example, I want to use the liveness probe and the readiness probe. They control different things, but the basic idea is that Kubernetes, before completing a rolling update, before completing a change for your application, is going to check these things, and it's going to block the deployment if these checks are not passing. So once again, I'm going to new deployment. Here there is an error. I'm going to do a new deployment. I just I changed the manifest, and I just added the liveness probe and the readiness probe. And I'm deploying the previous application, the previous version, v1. So Kubernetes running update. As you can see, like some statuses are returning OK, others are returning KO. Kubernetes is completing the deployment of the new version. Let's see. Running. There is one last container from the broken version. Cool. So now all the containers are running the working version, which is v1. Now I want to do the same thing that I did before, like deploying the broken version, but now I have the liveness probe and the readiness probe. So here again, I can change this to broken. I can again apply the app.yaml manifest. And now I can watch for changes in the pods. And what I expect is that I declare a new state to Kubernetes. Kubernetes, please deploy this new version of the application. But because there is the liveness probe and the readiness probe, and they are failing, in this case, the readiness probe is failing, Kubernetes will block the deployment and will keep the v1 version running. Okay. So as you can see, there is this new version, which is running. But if we dig into this and we do kubectl describe pod, and we pass the pod. So still, it's sad that it's super small, but I'm going to try to do this. You can see that there are some events. And one of the events is that the liveness probe failed, the readiness probe failed. So because all these checks are returning like a 400 status code, Kubernetes is not continuing the deployment. So, and last but not least, if I keep like checking my application, the working version is still there. And this is really cool. Like if you think like running an application at scale or running an application in production, this gives you a lot of powers, but also you feel more confident in running application, deploying application, and bringing new features to the customers as soon as possible, and all these sort of things. And Kubernetes will try to will keep continuing, because you declare a new state. So as soon as it can, as long as it can, it will try to deploy the broken version. But because you define some some checks, some probes, like in this case, like it won't be able to create new containers and all those sort of things. So because now I'm aware that the application is broken, something that I can do is to just stop the rollout, stop the the deployment. So what I can do is I can use the kube control again. I can call rollout undo, and I basically cancel the deployment because it's faulty. And now if I check the pods again, I can see that Kubernetes tells me, okay, like you decide to undo the deployment, so I'm going to terminate the container. I will stop keep trying to deploy this faulty application. Cool. So now I still have my working application, although there was a bug. And this is one of the few things that are really easy with Kubernetes. There are tons of things that you can do, but this is just a small thing. And I think I'm done with my talk. If you have any question.
Thank you for the talk. Let me unmute people. So we have a few questions from the stream. The first question was, I think you answered already on this one, okay, but I will still read it. Maybe you have some comments. The question was quite emotional. Really, do we have to drop Docker now, or it's still compatible with Docker if Docker is outdated, and what should we use instead? That was the first.
So that's a really good question. As a developer in general, you don't have to worry because Docker images are fully compatible. The only thing is that if you're running a Kubernetes cluster, the container runtime that you're going to run inside is going to change in the future. That's the only thing. Images are still compatible. And if you don't run a Kubernetes cluster, or if you're using a Kubernetes cluster, which is managed by AWS, Azure, DigitalOcean, or GCP, you don't have to worry about this.
Cool, thank you. And one more question. When you were presenting, the question was in the Zoom chat, wouldn't it be easier to just run the manage Py and then run server?
To run the manage Py and to run server. I guess that the question is, wouldn't it be easier to run the Django application like a simple Django application?
Yeah.
Yes, that's for sure on your computer. But then how do you plan to run this application elsewhere? I think that's always the question. Like, how do you connect your computer, your local machine, your local environment to a server or a machine which is running on the other side of the world? I mean, running on your computer, it's always the easiest thing. Like, the real problem is like, how do you run these things at scale? How do you run these things when you have multiple teams?
Okay, thank you. And there was one more question from Max. I think now you can unmute yourself and ask the question.
Hey, Christian, I was just wondering, do you have any advice for maybe people who are new to Kubernetes? Because often it can be quite daunting and quite a steep learning curve.
That's a really good question. So I'm creating a course which focuses only on developers. So that's probably a good resource where to start. The other thing is that there are a few resources, sadly, because Kubernetes is mainly targeting like the DevOps engineers or Ops teams. So I think the kind of knowledge is really missing. Like, there is a lot of knowledge outside, but it's really targeting like a different set of users. And like Kubernetes brings a lot of complexity, and most of 95% of this complexity is not really needed when you just deploy an application in Kubernetes. So that's a really good question. But I think there are a couple of courses, maybe a couple of books to deploy application in Kubernetes. But sadly, the majority of the resources that you can find are how to run Kubernetes, which is probably not what you want to use or what you want to do.
Cool, thanks.
We have one more question from the stream. Do you think that Kubernetes is a size-fit-all solution to run any software on production?
That's a really good question. I think they're really pushing into that direction. Like all the cloud providers are pretty much aligning on Kubernetes as a stack. So a good example is Google Cloud. Like, everything around virtual machines or workloads is going to be a container. Cloud Functions are containerized. Cloud Run are serverless workloads that are basically running on Kubernetes. Like this is going to be de facto the standard to run applications, and then I don't know, you can build your own components if you want to modify something. But like another cool thing about Kubernetes, okay, you can run application inside to modify the behavior of the cluster. So like you can create a PostgreSQL component. So every time that you create a new application, you also create a database. So these are all the things that you can do with Kubernetes. So I don't know whether it's going to fit all the needs or all, sort of requirements for your company or your team or your application, but for sure, like you can really stretch Kubernetes before breaking it.
Okay, we have more questions coming in. The next one would be, do you have to write your own health check in your application, or is it some Kubernetes magic or not? And that tries to figure out if your app is okay or not.
So you need to define the probes. So you need to define how Kubernetes is going to check your application. And then you need to define this L check inside your application. So in this case, I define the L check as inside my Django application, like API endpoint. But you need to define these two things. You need to define the L check inside your application, and you need to define the L check inside the manifest. And then Kubernetes will do the rest. But these are things that, as a developer, you should own. Like my application should work. Okay, how can I define that? Like, or is there a way to define that? Because maybe there is not a way. Maybe like you have a job and you didn't have a way to check your job. But generally speaking, for like API-based application, you always have a way to check whether your application is working correctly or not.
We have more questions. So thanks for the talk. Do you recommend running Kubernetes for development?
Yes, and I think there is a lot of effort on that, not just from the community, but also from other companies like building tools for Kubernetes. I really like what Rancher is doing with K3S and K3D. I think, and I thought before, that running Kubernetes on your computer was painful. Like they try different things, but like, again, because it's a system, it's not just a binary. It's like you need to have etc, you need to have, I don't know, kube controller and all this sort of thing. So it wasn't like an easy task. But now we're going to have distribution for Kubernetes. So basically, they're going to pack Kubernetes in a different way, and they're going to make it possible to run it on your computer in a really simple way. And K3S is an example of this. So it's I think they're trying to get into the cloud native foundation. So they're trying to take the project outside of Rancher and like trying to make it more open source. But yeah, the idea is to have different version of Kubernetes that, depending on your needs, like you can have Kubernetes for your local machine and Kubernetes for production, and they're going to share the same API, but they're going to be different. So they're going to be different binaries. So if you want to try Kubernetes on your computer, just Google K3D or K3S.
Yeah, I think there was a next question. If there are any issues to while running Docker image on premises, on Kubernetes on premises. So maybe.
Yes, if there is any issue on running Docker images on premise.
On Kubernetes on premise.
Yeah, on Kubernetes. So the thing with Docker is that it's not an official container runtime anymore, but the images that you build with Docker are still compatible. So on that side, there are no issues. The other thing that I will check is whether you're writing good Docker files for images. So it's mainly about security checks and whether you're, from the security perspective, they're good Docker files. That's the only thing that I will care about. But nothing will change about compatibility of Docker images.
Okay, thank you. So thank you, Christian. Thank you so much for joining today. And we will have a small break before the next talk. Let's meet at 8 here, the same place, and just listen for music for 10 minutes. And we'll have a great talk from Max at 8. So thank you again, and see you soon in 10 minutes. So welcome back from the break. Max, are you ready to start?
Sure am. All good. I will just
okay, cool.
share
Stage
my
is yours.
screen. Thank you. Okay. Cool. Can you see my screen okay?
Yes, perfect. Thank you.
Nice, cool. First, I'd just like to thank Christian for that interesting presentation. I think at Delivery Hero over the last year or two, we've seen pretty much every team transition to Kubernetes one way or another. It's basically everywhere now. Very important topic these days. But right now, I would like to talk about load testing a little bit, a topic I'm very interested in and work on a lot these days in my job. So I'll say why it's important, what makes a good load test, and a little introduction to Locust, which is a framework in Python. So my name is Max. I'm a systems engineer. I'm mainly working with cloud infrastructure, Kubernetes, and automation and topics like this. And I work at Delivery Hero. Our company delivers food and other things in lots of different places. If you're looking for a new job, hit us up. We're always hiring. So a bit of context today, because load testing is a pretty broad topic. Generally speaking, the context is mainly REST APIs. I would say 95% of the work we do in load testing is REST APIs these days. The context is also like production or live applications, where downtime is money. So the goal here is stability. And that's kind of the whole point of load testing, is to kind of increase stability. All our stuff is in the cloud. I guess most new companies are like that these days. But I don't want to limit the context just to this. Like, so for example, if you have a front-end application, the concepts in this presentation are also applicable. Same if your application is processing requests asynchronously, like from a queue, or if you're using gRPC, or if you're using bare metal and not the cloud, also all good. If you have any questions during the talk or after the talk, just hit me up. That's also fine. So load testing, what is it? Basically, you're generating traffic. You're targeting this traffic at an application. It runs for some time. Maybe 10 minutes is too short. Maybe 10 hours is too long. So somewhere in between. You collect metrics about the application during this test. That's very important. And then the performance of the application is evaluated using those metrics. You might ask yourself, why bother with this? Like, what's the point? And basically, it can show you the limits of your application. It can show you the limits of your infrastructure when they're different for your application. It can show you the behavior of your application when it's at or near its limits. And this can be interesting. You can reproduce like problems you've seen in a production environment and then test their fixes. Like maybe you have a performance degradation, then you can test the fix in a load test. And obviously tuning settings. In this tuning settings, this could be to get more performance, or it could be to make things more efficient, i.e. to save money. It can also offer some assurance when you have crazy high growth. This is a big problem for us. We have a lot of change everywhere in the company, and crazy, like the numbers are going up and up and up, and we need to run load tests to ensure that we can like confidently run double the load today, so that we're going to be okay in like a month or 6 months. But generally, all these topics is about stability. Sometimes it helps to start with a question when trying to do a load test. Yeah, for example, can my application do 400,000 RPM? Yeah, this is, to be honest, not a good question. It's too basic. What would be a better question is what is the limit of my application and why is it there? The reason this is a better question is because it gives you a lot more information. It can be a lot of effort to set up and run a load test. And lots of people who do this, they'll set it up just with one goal in mind, but they'll miss the analysis and not get all the knowledge from it. Another one that's super important is like, what will it cost me to increase the limit? Maybe you have some really low hanging fruit and you could get way more scalability for cheap. Yeah, it's another good question. Does my application performance degrade linearly? This is super important. If you have a database, often a relational database will just stop working at a certain point. It's all over. Other applications will degrade slowly over time, and this is quite different behavior. It can affect how you run your application. Why does it degrade? Monitoring threshold set correctly. What RPM does my application stop working? Things like this. Once you get into these topics, though, you're really just talking about limits the whole time, limits everywhere. So CPU is the most common limit, I think. It's the most expensive resource in the cloud. So if you've eliminated all the problems, then CPU would be generally speaking, the limit. Relational databases are also a big limit, and normally a hard limit because you can't scale them sideways, or you can only really scale them up and down, and this takes time. So CPU, I/O, CPU and I/O for databases is usually a limit. If you're going to eliminate these first two, then it's down to number of pods, like what Christian was talking about before. Number of pods is like the number of containers running in Kubernetes, or the number of cloud instances, or if you're using serverless, like serverless executions. And this is really kind of like the scale of your application. That could be a limit as well. And once you go past those, you get even more complicated limits as well. For example, if your application, let's say you're an e-commerce platform, or you're an online shop, and you'll have a checkout process, and you need to call a payment provider, then you're dependent on that payment provider. If the payment provider is down or slow, you are also down or slow. So the performance of just services and third parties also becomes important. Cloud provider limits, like Amazon or GCP, they won't let you just schedule 100 or 1,000 instances like that. They have limits, and you need to think about these limits as well. And often you find really annoying low-level limits that just go really basic back to computer science or system engineering stuff, like network bandwidth, open files, disk space even. And other limits like things that don't scale horizontally, like cron jobs and sort of scheduled processes. Non-auto-scaling resources like queue consumers and stuff. This can also be a limit you don't often think about. Yes. So these are the sorts of knowledge you can get from it, but if it's so great, then why doesn't everybody just do load testing? Yeah. The reason is really it's hard to set up and scale, or it can be quite hard to set up and scale. It can be quite challenging to write a realistic load test as well, like one that accurately represents what is happening in your live environment. It can be hard to measure the results. It can also be hard to isolate an application in a realistic way. We'll look at this in a little bit in a moment. The bottom line is it's hard. Writing a good test can be challenging, and automation can help, especially with the setup of a load test environment and running the test and collecting the results. But this is also quite difficult to set up, in my opinion. And time is money, and this is the main reason why a lot of people find load testing hard. It just takes a lot of time. So if you're going to write a load test, what makes a good test? And the main thing is realism. Yeah, the load you're generating has to look like the real application load you have. So realism, let's say. So to measure like your live traffic, you could look at request count. Yeah, so you could just say, oh yeah, I have this many requests coming through, and I make a load test that generates this many requests. That's pretty good. But this is like way too basic. The problem is that you have a request count here, but this could be get request, there could be post request, there could be the same request repeated over and over, and this might not be reflective in your load test. Yeah, it doesn't give enough information. Another thing or metric you could use is request status or request type. This obviously here you can see colors. This gives you a bit more information. This is showing HTTP status response, 200, 201, etc. And then maybe the load test generates this. Yeah, this is a fail, I think, as well, because it's not. You can see it's a different ratio of the green to the yellow. But also, there's no guarantee that this is like the real traffic. Yeah, the green within the green block there, 200, there could be different requests to different resources in your application. Some of them could be expensive and some of them maybe not. So again, there's no guarantee that even if the colors do match up here, that you have the same test or the same kind of traffic, and then it won't be realistic. And then the results are probably not very good. So what's a better way of doing it? Transactions is a good way. This is an example here I'll show you. So we have live traffic here. And this would be each one of these colors is like a transaction. Transactions mean different things in different contexts, but here it's basically a path to your API and the request type, like get or post or whatever. And then this unique combination is quite specific to your application. And yeah, so all of the blue could be expensive, or it might not be, but as long as that blue one is represented the same ratio in the load test, then it should be pretty accurate, broadly speaking. Then you can see some other requests here. So we have deliveries, delivery ID, get requests, we have a post request here. So here you have a lot more detail in the measurement and of the live traffic and the load test, and then you can see the ratio of the different request types or the different transactions, and this should give you a much more realistic load test. So another super important topic in load testing is test boundaries. I'm sure some of you have seen a microservice architecture. This picture here is quite common if you have like a tech company with lots of different teams doing different things. And yeah, there's quite a lot of complexity there. So if you were to imagine we wanted to load test this microservice here in the top right, shown in green, but then this service is calling these two other microservices, right? So you're kind of, by load testing the first one, the green one, you're also load testing the ones in red and their resources as well. So this dependency creates its own set of complexities. So if we're going to just isolate those apps here, so now we have to measure some metrics about our microservice, which is the top one. So let's say throughput, response times, CPU, memory, container metrics. But then if the performance of our dependent microservices also degrades, so does our service. Yeah, so we also have to concern ourselves a little bit with the performance of those services, which is a pain. Yeah, and then if those dependent services also have a database in this picture here, we also need to worry about the performance of that database. And so you end up in a situation where it's quite hard to isolate just your application to do the test, and then your scope gets bigger, and then you just end up with like way too many metrics. This adds complexity. If you add another microservice in here, there's more complexity and more complexity. And if you think about it, like now it's common for one team to have a microservices, like you write it, you run it kind of thing. Then so there might be 3 teams involved here in this picture. And then if you're a team running the load test for the top microservice, you also need to ensure that the other teams have their microservices running for the load test. Are they stable? Are they using a production version? Do they have the correct configuration, etc. So one way of dealing with this is, one, you just take on all that complexity, fine, you can do that. But another way is you can make it more isolated. So we want to load test the top microservice. So what we might do is remove these 2 microservices here and replace them with a mocking service, and then remove the databases. So this is a tool that can basically, it's designed for mocking other APIs basically. So you would have to tell the tool or the service what it expects in requests and what to send back as responses. And then once you've done that, then your microservice that you're testing doesn't know that it's just talking to a mock service, right? There's a little bit of work there to set that up, but then if you do this, you can then test your service in isolation. And this makes things faster and easier and just more simple in load testing. Of course, you lose a bit of realism here, of course, because now you have a mock service and not a real service. Yeah, but it's an interesting trade-off, and I think often one that pays off. Another question about load testing is how to measure results. This is a complicated topic, but generally speaking, response times, very important, very common. Container metrics, throttling, requests and limits, just basically is your container using a lot of CPU or a lot of memory or not. Application replicas, so this is like how many pods, like in Kubernetes, or how many cloud instances, like in GCP or Amazon. Or basically the scale of your application. And then any metrics for dependent services. So this could be other microservices that your app depends on, or it could be your app's database, or it could be your app's cache, like Redis or Memcache, or any other service it uses. Yeah, it could be a cloud service. The reason being is that if your app's database is slow or having problems, then your whole test is going to be slow, and that needs to be resolved. This is a deep topic. This whole YouTube video is just about measuring response times and all of this stuff. So I won't go into too much detail, but broadly speaking, response times and these items here are some things to look at while you're running your load test. Oh yeah, here's some screenshots from some of our monitoring systems we use during load tests. So this is showing request time percentiles. This is showing CPU usage of a container. This is showing the status of a horizontal pod autoscaler. This is a autoscaling tool used in Kubernetes. What else? CPU throttle seconds. It's also super important if you're running containerized load. And then database transaction screenshot. Just some random stuff that we use to monitor when a load test is happening and the health of it. So now we have to think about how to write a load test. Yeah. So like I've said before, realism is key. So we want to copy real behavior. This can be complicated. So if we imagine, let's imagine an e-commerce platform. A user might open the homepage, they might log in, they would, let's do a restaurant delivery service because that's what we do. So if you're on Volt in Berlin or what's the other one? Not Foodora, they're gone, Lieferando. Anyway, log in, you'll search for your own postcode, you'll look at a near restaurant, you might open a few restaurants, you would choose one of them, and then you would choose a few menu items, and then you would create an order on the thing for your meal. If we wanted to write a load test for this, like as in code, we would have to load our own page. We would have to log in with credentials. We'd have to select a random postcode from a list. So yeah, say a Berlin postcode. We would have to load the list of restaurants based on the postcode. We would have to load an amount of restaurant landing pages. Then we would select one from that subset from the previous step. Then we would load the menu from the restaurant and then add the menu items to the cart. Then we would go through the checkout process. So what you have on the left is like user behavior, and then what you have on the right is what the load test would be doing. So you can see here, it's sort of, let me just move that. Can I move? I can't see. Okay, cool. Run through that again. Yeah, so now you can see here, there's some important aspects in here, like the random postcode. Yeah, this has to follow a distribution of real postcodes, like real life use. Because if you're rendering any postcode at random from in Germany, for example, lots of postcodes will have no restaurants or just one restaurant or two or very few, right? And this is not accurate. So you'd have to load the postcode in a realistic way, yeah, and choose them in a distribution that's realistic. Same for loading restaurant landing pages. A user is not going to load 1,000 restaurant pages. It's just they're just going to load like 1 or 5. So there's also some thought goes into there. Menu items. A user is not going to fill up a menu with like 50 meals. It's going to be a subset. So again, you have to think about these little aspects that would affect the realism of your load test. Also, there's dependencies here as well. If you're selecting a random postcode, you need that to load the restaurant list, right? You get what I mean? And then you need to load a few restaurant landing pages, but you need the restaurant list to choose the restaurant. And then you need to select one from that restaurant list. So each of these steps is dependent on the previous step. And then, of course, to go through the checkout process, you need to log in. So this depends on the second step, but also you need to have a cart. Yeah, so that depends on the previous step. So if you look at this load test, and then you need to think about some tools to do this. And if you've done a little bit of load testing or thought about it before, common tools like AB, Apache Benchmark, curl, work, Siege, and Hey, like none of them can do this. If you want to create real load, these basic tools they're just not good enough. They don't have any logic in them. You can run a subset of requests for sure, and you can scale it very large, but it's not going to be realistic. Yeah, there's no conditions or anything like that. Another super common tool is Jmeter, a horrible tool, if I'm honest. Uses XML files. You've got to edit these crazy XML files. It has this crazy Java UI. Also, like really unuser friendly. And Goat is another one, which is running on Amazon Lambda, and it can go really high scale for sure, but also very basic. So if we're looking at the requirements to create a realistic load test like this, we need like a custom flow that repeats, like creating orders. We need custom flows that don't repeat, like getting credentials. Yeah, we don't want to log in 1,000 times because that's not realistic. We need conditions and loops. Need randomness is also super important. And then if we're looking at these requirements, there's only a few tools that actually do this. So if we're using Java and Scala, we can use Gatling, nice framework. If you're using JavaScript, you can use K6. If you're using Node.js, you can use Artillery. And if you're using Python like us, you can use Locust, and that's what we'll talk about a little bit in a minute. All of these are frameworks. So when you're writing a load test in Artillery, you're writing it in JavaScript. In JavaScript. And so this means you can write it in the language and the framework that you're familiar with, which is good for everyone. There's also cloud-based services. We don't use them, but they sort of take care of some of this complexity for you, especially scaling the load test to run it large if you need to. So now we get to Locust. So I think it's the most popular load test framework, if I'm not wrong, judging by GitHub stars anyway. I don't know if that's a good metric, but hey. It has a master worker model. So you have one part of Locust that is controlling a collection of workers. And this is how it scales up. Oops. And this master worker model is it's good because it allows you to scale horizontally, like cheap and easy and fast. So back to Christian's example, this would be a perfect scenario to run on Kubernetes because you can scale the worker horizontally, just increase the pod replica count. And then this gives you more like horsepower. This gives you more power to generate load. It provides a UI, some basic graphs, start-stop control. You can show live statistics of requests, latency, errors, and exceptions. It has a REST API, so you can start, stop the test and get statistics. There's the repo on GitHub. Yeah, here is what a load test in Locust looks like. This is called a Locust file. So you can see here, this is for a user. So HTTP user, this class here, this is supposed to represent a user. Wait time is basically the wait time it spends before going through the loop again. The task like ratio, so these numbers here, that is the task decorator. This is defining the ratio of each like request to the others. Yeah, this is super important. If we go back to that metric screenshot I was showing, not metric, the measurement screenshot here, if you want to reproduce this accurately, you need to be able to control it so that it's the same ratio as the live environment. Yeah, this is full realism, and that's how you can achieve this in Locust, by looking at these, using these task decorators. Yeah. Pretty simple, I think. I think underneath it's using the request library. Yeah, anyway, let's have a look and run. Okay, let's do a demo. All right. Let's get rid of that. Okay, here is that same Locus file here. Now, that is
Could you maybe make it a bit bigger?
Of course. How is that?
Yeah, looks good.
Okay, nice. Cool. So there's the Locus file there. It's the same one we just saw. And I have a terminal here, and I will make that bigger as well. Okay, so I'm using Docker Compose here. It's just running on my laptop. I'm going to scale this Compose collection of containers up, and I'm just going to set the worker count to 3. So run that now. You can see it's starting Locust. You can see the different names of the containers here. So the master, this is the Locust master, and then you can see the workers here, worker 1, worker 3, etc. And I have a target here, which is just Nginx basically. So now that that is started, we can go here. Let's run the Locust UI. So this is the Locust user interface. You can see here I can start a load test. You can see here the status is ready, and we have 3 workers. So let's do 100 users. Spawn rate of 1, so that means it'll start 1 user per second and slowly scale up the test. Let's start it. You can see now the status here is spawning. We have 3 workers, and you can see some requests here. Let me wider. Can I make this bigger? Oh, there we go. That's better. Okay, we have some charts here. Yep, so you can see total requests per second. So this is requests per second across all our Locust workers. You see response times here. We have a median and a 95th percentile. And then this is the amount of users we have running across all workers. So if we go back to the top here, we can see these are our 3 workers connected. So these are our Docker containers. You can see the state is spawning. This means they're slowly creating new users so that the load test is getting bigger. And each one has 16 users, oh, now 17. If we go back here, this is our overview of our requests. So you can, if we look at our load test file here, our Locust file, you can see here is restaurants, here is restaurants, Pizza Gazzo, and here's the homepage. And you can see these represented here. And then you have columns for the metrics for each of those requests, fails, request percentiles, etc., and the current throughput. So what we should see here is the homepage request count and the restaurant request count and the restaurant's Pizza Gazzo request count should be respecting the ratio of these task decorators here. I think this test is not actually very realistic because I don't think a real user is going to load the homepage 10 times more than a restaurant page, but hey, anyway. Yeah, you can see it's slowly ramping up here, around 60 requests per second. And you can see here it's hit the top. So now it's not going to scale up anymore because we set it to 100. We can also edit the test. So then let's, I don't know, go to 50. And we'll scale that down to 10. And then this will scale the test back down again. So we can control it live as well. Very basic. Yeah, so maybe we look at a more complicated example now. Let's have a look. Did that start going down? Where's my charts? Here, and you can see it scaled down very quickly. And now it's on 50. Very nice. I will stop this. Okay, so I'll just kill those containers now. Now we'll look at a more complicated example. This one here. Now let me just edit this. So we're running the more complicated example now. Save that. So this is a Locus file for something a little bit more complicated, like I was saying. I was struggling to find a good example. We have lots of complexity and that I can examples at Delivery Hero, but they're all quite not good examples to show because they're quite niche and custom. But here you can see we have an HTTP user. We have some settings up here. On start, which is a special method that's called just at the start of the load test once. So we want to log in to an API. So we have an environment variable for this. And if the response code from this is 200, then we're going to save the response from the token API. Yeah. So this will be saved and this will be used in these requests here. You can see the headers here are authorization, and then it's using the API authentication that was got in this first request here. You can also see here, there's a little bit of randomness. So if you look at this URL, we're injecting into here a random choice of available locales and available country codes. And then to this one, available locales and available language codes. So this is a multi-language API thing that I just took as an example. Yeah, so we're seeing a little bit of randomization here, which is good. We're seeing a little bit of complexity where we need to authenticate first and then save those credentials. Yeah, let's run it. Okay, so it's starting our containers again. Jump back here, let's refresh this. It's been reset. So like before, let's maybe go 100 users at 1 spawn rate. Wait for it to load. Okay. So now you can see we're doing a post to OAuth token. This should be very few requests because like it's shown here, it's just when the user starts, it's not repeated over and over. And then you can see these requests here are being run, and you can see the response times and stuff here. And then again, you can see our graphs here, response times here, a little bit inconsistent. And our throughput here, request per second, is here. You can also see failures here. So if you have any requests that fail, like they fail with a 400 or a 500 or whatever, they will be listed here. Any exceptions, tracebacks, like if you make a mistake in your load test or there's an unhandled exception, like the data that comes back from an API is not what your code is expecting, you will get exceptions in here. The load test will keep running. It just counts the exceptions, counts the occurrences of them. And you can download your data here as well. You can get them in CSV and whatnot. Yeah, so I will stop that now. Yeah, that's it. That was a brief overview of load testing, why it's hard, why you should be doing it. And that's the end. So what is the limit of your application and why is it there? A question for you. Maybe you should think about it if you're running something live. Also, if you find this interesting, we're always hiring people. Thank you.
Thank you, Max. It was a great talk. And we have one question from the stream. Sure. Is the load testing hitting the actual live application running in production? And then the second part, wouldn't that interfere with real life traffic?
100%, great question. Yeah, generally speaking, no, we have an environment that is specifically created to be exactly like live, and we use this. Some people do use live though in downtime, and people have done this in the past. It's obviously complicated. So if you have time in the day when your app is not used, you could do this. This saves you money in having infrastructure for a separate environment, but it has other complications. So, yeah.
We have a couple of more questions
sure.
coming from the chat in here.
Mm-hmm.
The next one would be, could you please elaborate on the problem about using Jmeter?
Yeah, sure. I mean, it's no problem using Jmeter. It's just a really old tool. It's been around for so many years. It's no problem. It's just if I go back to the slide here, let me just jump out of presentation mode. Like, if you want to do this flow here, like writing that in a Jmeter file in XML, it's just a nightmare. It's a nightmare. Yeah. And so if you compare writing just this logic in Python, you can imagine this in your head, I'm sure. Compared with Jmeter, it's 100 times easier and more user-friendly to do this in pure Python code.
Thank you. There are more questions coming in. So the next one would be, how often do you run your load tests and how often do you recalibrate your load test traffic on your current production traffic?
Yes, so I mean, like I said in the beginning, if it's not realistic, then it's not very useful and you have to recalibrate it, especially we have really high growth. So you do a load test the beginning of the month and things might have changed by the end of the month or by the end of the next month. So it's up to development teams. Like I'm sort of helping developers do this. I'm sort of helping developers overall running load testing, but delivery here is big. Like developers need to be responsible for their own tests. So they need to check every month, every 2 months. They need to know what their application is doing when there are changes, and then they need to update the load test to reflect both the scale of the live environment and any changes in the API in the live environment.
Thank you. More questions from the stream. So I'm mixing the stream questions and the chat questions, so don't get offended for people who are here. I will ask all of them for sure. We have time. So then the next question is question from Robert. How do you bring the metrics from Locust monitoring response times and the metrics from the backend service CPU together in one tool?
Very good question. Just to like frame it a little bit. So Locust itself is generating metrics. Like you saw in those graphs there, it's measuring response times and stuff like this. Yeah. Invariably in a live environment, you also have a monitoring system that is maybe, I don't know, Prometheus and Grafana. It could be New Relic or Datadog or whatever. So in this scenario, when you run a load test, you have metrics from Locust or whatever tool you're using for load testing, and you have metrics from your monitoring system. Personally, I'm not a fan of using the metrics from the load test itself because, like I said in the beginning, the goal is stability. And if you're running a live environment, you're using your own monitoring tool day to day. And for me, I think it's better to use your day-to-day monitoring tool for evaluating the results of the load test and not mix it up with the metrics that come from the load testing tool itself. Of course, there's situations when you can see failures in the load test tool that don't show in the monitoring tool. You need to keep an eye on this, but generally speaking, I would prefer to always use the monitoring tool that you use day to day in the live environment.
Thank you. One more question. I think it was related to when you were talking about different environments. Mm-hmm. Do these test frameworks give the same test results?
You mean like, yeah, okay, if you're using the different framework tools like Gatling and stuff like this. I mean, they should, not in the different tools, they operate in different ways. There's a lot of intricate details there. So I think it would be pretty, I mean, they're ultimately doing HTTP requests. So if you can have really good control of the tool, the results should be the same. But if you're just writing a basic test in each tool, there's little settings that you will get different results if you don't have a really, really deep understanding of what those settings are. And they're also written in different ways, like Locust is in Python. Python is using, I think it's the GivEnt library for concurrency. Concurrency in Java is just completely different. And so I think on the surface, no, you won't get the same results. But if you know your load testing, you should be able to get the same results in the end.
Thank you. We have more questions coming in. So
Sure.
The next one, how do you bootstrap your test application with properly sized realistic data?
Yeah, I mean, we run tons of load tests all applications. So it's hard for me to say one answer that is across the board true. But essentially, again, it's the job of developers to own the load test. Yeah, I maybe I look after the framework and stuff, but a developer needs to know, maybe copy data from a production database, anonymize it for GDPR and all of this, and then put this snapshot or database into the load test database instance. And then maybe make sure that instance is the same size as production, so you're going to get like accurate results. I'd say that's broadly the process. Yeah, you have to make sure it's like production always, because that's the whole point, realism. That process, copying it over, anonymizing, this can be a real headache. Some applications, but this is possible if you're using, for example, DynamoDB. Yeah, you can create a snapshot to S3, and yeah, this is another complexity. It really depends on the application, but always the goal is to be like the live environment, and this generally means copying data over, and this could be periodically.
Thank you. One more question from the Zoom chat. What APM RUM tools do you use?
We currently, what APM and what tool? What was the second word? APM and RAM?
RUM, R-U-M.
RUM, okay. I don't know what RUM is, but APM, we use New Relic currently, and now we're switching to Datadog. So yeah, APM super important. There's metrics you can get in APM that you can't get in other tools. This is one example here. This is showing you what your application is doing at a low level, and it's difficult to get this data from a tool that is an APM. Yeah. So yeah, we're using these screenshots are from New Relic. Yeah.
Okay, cool, thanks. And more questions from the stream. Is there a risk of your web server caching requests from Locust, which would give a wrong idea of your application's performance?
For sure. Yes, I mean, this is a risk, I guess, but if the application is configured like live, which is always the goal, then it shouldn't be this way. Yeah. If live application is not caching requests, then the load test environment shouldn't cache requests either. Perhaps there's a mistake someone made in the setup where they set up the load test environment. It's not really a copy of live, and maybe live isn't caching and the load test environment is. This would obviously be a mistake, and this needs to be rectified.
Okay, and a related question might be also from the stream. In your example, the load tests went fine. How would you approach the situation when failures occur? I mean, it's a big topic. There's so many difficult problems that come with failures and load tests, honestly. Like, I've spent hours and hours with developers debugging load tests. Once you have a complicated test, like, it can be really tricky, but you have to look at request failure. Yeah, maybe just one request is failing. This will give you a clue as to what it is. If you have an APM solution, this can help you accelerate debugging because it can tell you exactly where the error is. If you have issues with dependent services, like I was saying before, like isolation can be better. This is a total nightmare. I mean, you're back to debugging like you would in a live environment, reading logs, looking at requests, looking at metrics. It's not any easier in a load test environment, to be honest. Okay, thanks. And one more question from the Zoom chat. Does Locust provide its metrics also in machine readable format?
Yeah, sure. I mean, let's go back here, download data, there's CSV there. And you can get all the metrics from there's a metrics API. So this application here it's just JavaScript running in the browser. So this is calling the REST API of Locust to get the metrics that produces this table. So you can get those metrics, or you can download in CSV here. Any more questions?
Okay, cool. We are done with the questions from all the chats and from the stream. So anyone wants to unmute him or herself and ask a question? Okay, everyone is super happy. Thank you so much, Max. We have a small closing session and maybe Theo can start sharing. Thanks again for this great talk, Max.
Thank you.
Hey, everyone. Thanks for joining this year's first PyBerlin event. Thanks to today's speakers, Christian and Max, for talking with us about two fascinating topics. And lastly, thanks to our sponsor, Scoutbee, for providing us with a premium Zoom account today. Our next meetup is scheduled to take place in exactly 4 weeks. And everyone is very welcome to contribute to PyBerlin, and we can always use some extra help. Please reach out to us if you're interested in helping out. We're also looking for speakers and panelists. If you have an idea and would like to talk at PyBerlin, please reach out to us. You can use this link for submitting a proposal. And don't forget to follow us on Twitter, spread the word about PyBerlin, and feel free to join the Berlin Python community Slack at pythonberlin/slack.herokuapp.com. That's it for today. Enjoy the rest of your evening. Take care and see you next time.